What's up, everyone? Sorry I couldn't be here today, but I did want to make sure that before you take the quiz today that we go over the final two problems that I did not get to in our 3.5 notes. They're both really, really good problems, and I want to make sure you see how they're done. So here's the first one. Log of x minus 1/2 log of x plus 4 equals 1. So we can't utilize the definition of a log where we change a log equation into an exponential equation until we have a single log. So I need to use my properties to take these two logs and combine them together. So I do see subtraction. I see a log minus another log. And we do know that subtraction can come together with division. But first, the rule says log minus log is log of r divided by s. So it'd be log of r minus log of s equals log of r divided by s. So I can't have this 1/2 here. And that's very easy to get rid of because I could take the power rule and I can take this 1/2 and I can move it up here as the power. And of course, a 1/2 power is a square root. So let me go ahead and do that first. So I have, actually, you know what? I'm going to start my work over here because I need a little bit of room for this problem. All right, so I have log of x minus log of the square root of x plus 4. All I did was put that 1/2 power up there equals 1. Now I could bring that division, or excuse me, the subtraction together with division. So I have x is my numerator, and my denominator is going to be the square root of x plus 4. That is the quotient rule in reverse. All right, now that I have a single log, now I'm ready to just simply use the definition to help me solve it. So the definition of a log, converting it to exponential form, is my base of 10. Logs equal my power, so my power is 1, and that's pretty easy. 10 raised to the first is 10, equals the inside, which is x over the square root of x plus 4. Now at this point, 10 to the 1 is just 10, so I actually could kind of erase that 1. 10 to the 1 is just 2. Well, excuse me, 2. Oh boy. 10 to the first is just 10. So now I have, honestly, a pretty easy equation to solve, but I will admit, in terms of a scale of easy to harder equations, this is a little bit on the harder side, but easy in my eyes, maybe. All right, so now I got to solve this. All right, so first thing I'm going to do is, essentially, I'm going to cross multiply. I have 10 over 1, fraction equals a fraction. I'm going to cross multiply. So I get 10 times the square root of x plus 4 equals 1 times x is x. Now, please do not distribute the 10. You can't. A square root is not a parenthesis that could be distributed, so it's just 10 times the square root of x plus 4. All right, now my thought is I need to solve for x. I already got x on the right, but there's also an x on the left. So I need that square root to go away. That's pretty easy to do because we learned to get a square root to go away, all you got to do is square it. So got to be fair here. If I square the left side, I got to square the right side. So I'm going to square both sides. That's keeping me pretty equal, not changing anything majorly. But here's where we got to be careful. The right-hand side, that's easy. X squared. Doesn't get much easier than that. On the left-hand side, it's got to be careful because everything needs to be squared. So 10 has to be squared. Well, that's 100. And then the good news is when you square the square root cancels, and we just get x plus 4. No more square root. Now that 100 can be distributed, and I have 100x plus 400x equals x squared. At this point, I got myself a very basic quadratic equation. So first thing I got to do is I got to get a 0 on one side. So I am going to move everything to the right-hand side. So I got my x squared. I'm going to subtract the 100x over, and then I'm going to subtract the 400 over. And I made a mistake down here. I'm so sorry. I'm just having a rough day. When I distribute the 100, that's a 100x and a 400, not a 400x, just 400. There's no x there. All right, so subtract everything to the right side. So I have x squared minus 100x minus 400. All right, now I got a quadratic. We got 3 ways to solve a quadratic. Complete the square. Actually, wouldn't be that hard here. I can factor, or I can use the quadratic formula. Whatever you want to do. It really doesn't matter. I'm actually going to go ahead and complete the square just because, well, I think it's kind of fun. All right, so to complete the square, I'm going to first start off with x squared minus 100x. I'm going to move the minus 400 way over here for a second. All right, I already got a 1 right here. Makes completing the square way easier. Half of negative 100 is negative 50. And negative 50 squared is 2,500. So I'm going to add on a 2,500 here. And I can't just add a 2,500 unless on the same side I also subtract a 2,500. All right, so now I'm going to factor this part, which is going to be kind of nice. So that's going to be x minus 50 squared. Again, that's the x squared. That's the negative 100x in the middle. And then the negative 50 squared is the 2,500. And then I have negative 400 minus 2,500 is minus 2,900. Not too bad, right? All right, now, again, this is why I love completing the square. Now it's pretty easy to solve, so I'm going to add the 2,900 to the other side. So I'm going to add that 2,900 over. Equals x minus 50 squared. Now I'm going to go ahead and square root both sides. And remember, when you take a square root, you got to remember the plus or the minus. So the right side's the easy side because the square and the square root cancel, and I just get x minus 50. Now, I mean, it wouldn't be the end of the world if I left it as the square root of 2,900, but, you know, hopefully you guys know about reducing. That is 29 times 100. That's pretty easy to see, 29 times 100. 100 is a perfect square, so that could come out as a 10, and then the 29 is left in there. But I'll be honest, if you left as a square root of 2,900, it wouldn't be the end of the world, but we do like to clean up our square roots, and hopefully that's a pretty easy one to see, 29 times 100. 100 comes out as the 10. So now one more step, I'm just going to add the 50 to the other side, so I get 50 plus or minus 10 radical 29 equals x. Now, in these problems, sometimes it's nice to kind of think about what the approximate answers are. I mean, that's a pretty weird number, but if we go ahead and actually get the approximate answers using your calculator, 50 plus 10 radical 29 is approximately 103.852. That's a great answer. And then the other one would be 50 minus 10 radical 29, and that approximate answer is negative 3.852. But if you're really checking your work, that right here is an extraneous solution. Because remember, if you go back to the original problem, if you plug in one of your values for x, you can't get a negative inside of a log. So if I plug in negative 3.852 right here, I'm going to get a negative in a log, and that does not exist. Can't do it. Now, if I plug it in here, it works, because negative 3.852 plus 4 is a positive number, but it doesn't matter. If I plug it in here, it doesn't work. If it doesn't work in one log, can't use it at all. Now, the 103.852, that could work in either one of these logs. It's going to create a positive number. Nothing wrong with positive numbers whatsoever. So I do have one really, really correct answer. The exact answer is 50 plus 10 radical 29, nice and reduced. The approximate answer is 103.852. Both of those answers are great for me right now. I did show completing the square work, but I will say this is not factorable, but you could go ahead and use the quadratic formula. You have to do a little bit of reducing and stuff, kind of like I did. We're reducing the square root of 2,900, but once you do all that reducing properly, you should get the same answer as me. So that's how to do that problem. That's a pretty challenging problem, but it's a good one. It utilizes a tough solving, but starts off with using some logs, so the beginning was actually the easy part. All right, one more video for that final problem over cooling.